All right, so we're talking about Newton's first law, which is objects in motion tend to stay in motion and objects at rest tend to stay at rest. And so we have a couple demonstrations here. Newton's first law speaks to a property that we call inertia, and that's where mass actually comes from. So inertia is a quantity that describes the amount that an object wants to stay in motion or wants to stay at rest. And so to quantify that, we use mass. So if something has a smaller mass, like say this cutting board here, fairly light, it has low inertia. So if it's moving, I can very easily alter its movement. Or if it's at rest, I can very easily move it from rest. So what that means is if you would hold this on your head there, if I were to bang on your head with this hammer, it would not take very much force applied to that cutting board for you to feel it on your head because the cutting board has low inertia. And so just a little bit of force would get that cutting board moving and applying that force to your head, right? So I'm going to do very gently. You feel that? It's uncomfortable, right? If I did a little bit harder, ouch, right? Ouch. Okay, so now, thank you. If we give the cutting board a little bit more mass underneath it, you can hold all those textbooks on your head. You have to hold the books as well. You good? Mm-hmm. Now we have more mass, more inertia. And so this whole unit here is at rest. And if we apply force to it, right? If I apply a little force to it left and right, she's bouncing a little bit, but it's harder to get going any direction. And so if I bang on it with a hammer, there's less movement of the whole body. So she's been struggling here with books on her head. We better bang on her for a while, huh? So this is about as hard as I hit from the first one. That was about maybe the hardest hit. Yeah. Didn't feel it too much, right? What if I went a little bit harder?
A little more. Yeah.
You can go a little more? Look at her. Hopefully you could tell. I'm really banging. I was hitting about maybe 2 or 3 times as much with the books as without. And that is because the books have a lot of mass and higher inertia. All right, so how about another demonstration here? I'm gonna move the camera, don't get sick. All right, so here we have a mug. All right, and it has a string attached to it, right? I don't know if you can see the string, but it has a string attached to the mug. Now, if I pull on this string, I'm winding this back up here. If I pull on this string very lightly, I can lift the mug up. The mug has a certain inertia, right? It has a certain mass. It's relatively high compared to what this string is. But if I pull slowly, I'm not trying to accelerate it too much, so I'm not asking too much of it. But if I pull faster, I'm trying to accelerate this high mass object more than it wishes to be accelerated. And so the string breaks and it resists the motion. It resists the acceleration. And that is Newton's first law and inertia. All right, thanks.